Okay, so this is the second of the 11T6 lesson series of videos. This will be about some of the things we've covered in the last 2 weeks or so since the last video. Again, it's going to be a bit rough and ready, being filmed on a Friday evening after a long week at work, so I'll try and squeeze in some of the things we've done and you can forgive any mistakes. So it's going to be a whistle-stop tour of some of the things that we've been doing. We've just been revising lots and lots of key skills lately, so let's start. So converting units was one of the first things we've talked about recently, metric units that is. So some of the key prefixes that indicate that a unit of measurement is metric are these three, so centi, million, kilo. So if you can stick one of these words in front of a unit and it still makes sense to you, then you know it's in the metric system. So for instance, if I stick the unit meter, then kilometer, millimeter, centimeter, they all make sense. So meter is a metric unit. Some other ones would be gram, so kilogram, milligram, and so on. The other ones, the ones that are imperial, the other way of measuring things, are things where it doesn't make sense to put those prefixes in front of it. So kilo, mile, millimile, and so on don't make sense. So the exam typically asks you for metric units, so focus on ones where these prefixes make sense. Let's try and get a bit more focus on there. Okay, so if we convert some things, let's say we're going to convert 3.2 centimeters to millimeters. Well, we know that 1 centimeter equals 10 millimeters, so I will do 3.2 times 10. There'll be 10 times as many millimeters as there were centimeters, which gives me 32 millimeters. If I wanted to do, so the key thing is to identify the conversion that you're going to be using. So 1 centimeter is 10 millimeters. So another one would be, let's say we've got 2,800 meters, and we're going to change that to kilometers. Then I need to identify the relationship between meters and kilometers. So 1,000 meters equals 1 kilometer. Therefore, there's going to be 1,000 times less kilometers than there are meters. So I'm going to divide this number by 1,000. So that means moving the point 3 times. That would give me 2.8. Okay. We also looked at negative numbers again. So multiplying negatives, first of all, multiplying and dividing negatives, there are rules for these. So we know that 3 times 4 is 12. Now if I make one of those numbers negative, so for instance minus 3 times 4, so I've made one of the numbers negative, then the answer is negative as well. And it's still 3 times 4, I'll always do 3 times 4. The rules just help me decide whether the answer is positive or negative. So once again, if one of them is negative, then the answer is negative. And actually it doesn't matter which one is negative. So this time I've made the 4 negative. So long as one of them is negative, the answer is negative. The strange thing is that when both numbers are negative, so minus 3 times minus 4, then I go back to having a positive answer. So just keep in mind that it's when there is one negative that I get a negative answer, otherwise I get a positive answer. And that's important when I am squaring numbers. Remember, squaring means to times a number by itself. So if I were to do minus 3 squared, now that will be a positive answer, because what it actually means is minus 3 times itself. So minus 3 times minus 3, so the answer is 9. And the point that this raises is that it's impossible to square a number and get a negative answer, because whether my answer is positive, such as 4 squared, which gives me 16, or minus 4 squared, which gives me minus 4 times minus 4, the answer is still 16. So there's nothing I can square to get a negative answer. So whenever you square something, you'll always get a positive answer. Okay, so that's multiplying. Dividing is much the same. So if I've got let's start with a positive one, 20 divided by 5 equals 4. If I make one of the numbers negative, so minus 20 divided by 5, that gives me a negative answer. So same rule, if one of them is negative, negative answer. And again, it doesn't matter which one is negative. 20 divided by minus 5, that gives me a negative answer, because one of them is negative. But if both of them are negative, just like with multiplication, so minus 20 divided by minus 5, then strangely I go back to having a positive answer. So if one of them is negative, negative answer, but if both are, positive answer. Now this rule applies just to multiplication and division. I should probably just illustrate as well. If there's a chain of numbers to multiply, so for instance 3 times 2 times 5, so that's 3 times 2 is 6, times 5 is 30. Same rule, so if one of them is negative, like this, then I get a negative answer. There's my negative. If two of them are negative, just like before, I'll get a positive answer. But I should also point out that if three of them are negative, then I go back to a negative answer. So the first one kind of makes the answer negative, the second one, as we've seen, makes the answer back to positive, and the third one would make it back to negative. And if there was a fourth one as well, we would go back to positive. So you can see it alternates. Okay, now with adding and subtracting, so let's say I've got 6 take 2. Obviously that's 4, but what I want to illustrate here is that when you're adding and subtracting, you've got a number that you start with, so you can imagine that number on a thermometer, for instance. Then you've got either a plus or a subtract, and that indicates whether you're going to be going, I'm going to refer to it as warmer or colder, hotter or colder. So add means warmer, if we think of temperature, and minus means colder. So what this actually means, this simple sum, is that I'm starting with a temperature of 6 and I'm getting colder by 2. So my temperature is now 4. And I think it's quite helpful to keep in mind this idea of the kind of vertical number line or thermometer. So there's 0, 1, 2, 3, 4, 5, and then downward you've got minus 1, minus 2, minus 3, minus 4, minus 5. So let's do another one. So if I do minus 2 take away 4, then this is just moving up and down a number line. So multiplication and division that we looked at, there are rules about whether the answer is positive or negative, but with addition and subtraction you just move up and down a thermometer, if you like, and wherever you end up is where you end up, and that might be positive, it might be negative. So let's look at this one first. So minus 2, so that means I'm starting at a temperature of minus 2 and I'm getting colder by 4. So if I start at minus 2 and I'll get colder by 4, 1, 2, 3, 4, you can see I'll be down at minus 6. Minus 3, add 1, means I'm starting at a temperature of minus 3 and I'm getting warmer, so plus means warmer, warmer by 1. So temperature of minus 3, warmer by 1, means temperature is minus 3, warmer by 1, takes me up to negative 2. Okay, so far not too complicated, but what happens if I am doing, for instance, minus 3 take away negative 5? Now, take away negative 5 is a bit more complicated. Using my temperature analogy, I don't actually know whether I'm getting warmer or colder, because there's two symbols next to each other. So my guidance to you is to simplify these two symbols into one. And there are rules again for that. So if there are two negatives there, then they form a positive. And we've talked about that this is a kind of face and he's happily asleep there. So two negatives there make that positive. So it now actually means -3 add 5. And once we understand that, we can go back to our previous analogy, which means temperature is -3 and we're getting warmer by 5. So temperature is -3 and we're getting warmer by 1, 2, 3, 4, 5. So we go up to +2. Another example would be -3 add -5. So here again we've got to simplify these two symbols because we don't know whether that means to get hotter or colder, and when there's one of each, that does mean colder, it means take away. So when we add a negative, it's the same as just taking away, and we've talked about this being a face and this person being bashed in the eye, so he's not happy. So -3, this means -3 then -5, colder by 5. So temperature's -3, getting colder by 5. Temperature's -3, colder by 5. 1, 2, 3, 4, 5 would end up at -8. So that's a quick recap of the rules of adding and subtracting and multiplying and dividing with negative numbers. We've also been doing some work with finding areas, and I've given you some shapes such as these. So these are some rectangles put together. If I give you that the measurements are 5 and 2 and 3 and 6 like this, and I ask you to find, if I shade two of those rectangles like this and ask you to find the fraction of the overall shape that is shaded, then assuming these are all perfect rectangles, which they don't look like on this drawing of course, what I'm going to do is work out the area of these shaded bits. So this one here is 5 wide and the length of it is the same as this side, so it's 5 by 6 for this top shaded rectangle. So 5 times 6, it's 30 squares in area. This small rectangle down here is 3 long by 2 wide, and it's 2 wide because the top there's 2 as well, so that's 2 wide. So this is 2 by 3, this is 6 squares. So the complete shaded region is 36 squares, and so the fraction of the overall shape that's shaded is 36 squares out of the total. So we need to look at the total now. So the total length or width of this rectangle here is 5 plus 2, so that's 7, and the total length is 6 plus 3, so that's 9. So the overall shape, the area of the overall shape is 7 times 9, so 63 squares. So the fraction that's shaded is 36 squares out of 63 squares, and this simplifies. So if I can see they're in the 3 times table, so I'll divide by 3 and get 12 over 21. I can see they're both in the 3 times table again, so that's 4 over 7. So 4/7 of the overall shape is shaded. Okay, we've also looked at when we've got questions that have scales in them. So often we have a question where there's a model, for instance, and of a real life area or place or building or something like that. So it might have a scale of 1 centimetre on the model represents a certain number of, let's say, 3 meters, a certain distance or measurement in real life. So let's say we've got a scale model of a building, then on the scale model 1 centimetre represents a real distance of 3 meters. And then you might be required to change from some measurements on the scale model to some measurements in real life, or vice versa. So for instance, let's say there's a model of a building, it's 1 centimetre on the model is equal to 3 meters in real life, and the question would be what is 5 centimeters on the model in real life? So what I would do is say, I tend to draw a little table and just say, well, if 1 is 3, so 1 is 3. Now forget about units for the moment, I'm just looking at the relationship between the numbers. So this number is 3 times bigger than this number, and that's the important thing, spotting that relationship. So I've stripped off the units here because I know that these are centimetres and these are metres. What I'm looking at is the fact that this number is 3 times bigger than this. So if I then said, well, what's 5 centimetres in real life, then I know to simply multiply that by 3, and so it would be 15 metres. So 5 centimetres on the model is 15 metres in real life. And if I've given the reverse, and the question is, there's a section of a building that's 45 metres long, how long would it be on the scale model? Then I need to know what multiplied by 3 makes 45. Or in other words, I could divide by 3 to find that 15 centimetres multiplied by 3 is 45. So the key thing with a scale is to identify the relationship between the two numbers. Can I multiply one of them by something to get to the other? And that relationship will be true whatever the measurements are. Okay, so that's scales. We then looked at, I did some revision around different forms of average. So if I give you some numbers, 7, 8, 9, 8 and 6, and let's work out all the averages. So the mean is where I add them up and divide. So I'll do 7 add 8 is 15, add 9 is 24, add 8 is 32, add 6 is 38, and I need to divide that by how many there are. So 38 divided by 5 would be the mean. So add them all up and share them back out again, in other words. So 38 divided by 5. Now one way of dividing by 5 we looked at is to say, well, instead of splitting it into 5 equal bits, I'll split it into 10 equal bits because that's easier. So I'll actually do 38 divided by 10 because that's easier, that's 3.8. But I only wanted it split into 5 equal bits. So if I put 2 of these 10 bits together, that'll be the same as if I had divided by 5. So I'm splitting it into 10 bits and putting 2 of those together, so I'll have 5 bits. So that means to get the answer to this, I can do 3.8 times 2, which is 7.6. So the mean average is 7.6. The mode is the most common. So 8 comes up more frequently than any other, so that's a simple answer. The median is the middle one once they're in order, of course. So I'll need to put them in order. So I'll rewrite them 6, 7, 8, 8 and 9, and then circle the middle one. So the median is also 8. Now the range, which is not technically an average, the range is a measure of how spread out the items of data are. And by spread out I mean the gap between the smallest one and the biggest one. So the gap between 6 and 9 is a gap of 3, so the range is 3. Okay, so we've also looked at some probability. So let's say I was given a situation where I've got spinner A and spinner B. Spinner A has the numbers 1 to 3 on it, and spinner B has the numbers, say, 4 to 6 on it. The first step might be that I'm required to list all the possible outcomes of these two things. A quick way of doing that would be to draw a little table and say spinner A is over here, spinner B is up here. So the outcomes on spinner A are 1, 2 and 3. The outcomes on spinner B are 4, 5 and 6. Now depending on what I'm being asked to do, the question might say, for instance, I spin the two spinners and I add the numbers together. So if that's the case, then I can put the answers in this table. So if I've got to add the number I spin on spinner A with the number I spin on spinner B, then I can put a 5 there, because 1 plus 4 is 5. And I can put a 6 here, because 1 plus 5 is 6, and a 7 there, and I can carry on doing that. 7, 8, 9. So there are 9 possible outcomes from these two events. If I spin these two spinners and add them up, and these are the answers I get. So let's say I'm now asked, what's the probability that the total I get from the two spinners is a square number, for instance. Then the square numbers, I might remember, are the answers to these questions. 1 times 1, so 1's a square number. 2 times 2, so 4's a square number. 3 times 3, so 9's a square number. And 4 times 4, so 16's a square number. So which of these square numbers, 1, 4, 9 and 16, are available on here? The only one I've got is 9, I think. So the probability of a square number, probability of a square number equals 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 out of 9 possible outcomes. So the probability of a square number is 1 out of 9. Right, while we're looking at square numbers, we might as well quickly look at cube numbers as well. So cube numbers are kind of going a step further from square numbers. So 1's a cube number because it's the answer to 1 times 1 times 1. 8 is a cube number because it's the answer to 2 times 2 times 2. So this process of multiplying a number by itself and then again is called cubing, and the result of that are called cube numbers or cubes. So the next one is 27 because that's the answer to 3 times 3 times 3. 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. Now, and they're the only ones you need to recognise. So you need to kind of have a familiarity with these first five cube numbers: 1, 8, 27, 64, and 125. Right, we looked at also rounding, and let's say that I have a large number, 65,891, and I'll ask you to round that to one significant figure. That means I look for the first digit that's not a 0, so that one there. That's the most important one, or significant one, because it represents the most amount of, for instance, money. If this was money, it would be £60,000 versus, for instance, this 9, which would just be £90. So the first significant figure just means the first important figure, so it's always the first one on the left, basically. So this means rounds to the nearest 10,000. So it means basically give a rough idea of the number, a really rough idea. So this is going to be 70,000. The reason it's 70,000 and not 60,000 is because this next digit here was a 5. So if that's a 5 or bigger, then it means it's closest to this is closer to 70,000 than 60,000. So this is when I've rounded a number to one significant figure. I know that because there's only one figure that's not a 0. So I know I've rounded it to one significant figure. And to give you an example to contrast with that, if I said round this number 68254 and I ask you to round it to two significant figures, then these are my first two, so the answer would be 68,000. So two significant figures, there are only two digits that aren't 0. So again, I've just given a rough idea of it, but I've kept two digits that aren't 0s, the rest have changed to 0s. Okay. Right, following on from that, a quick reminder of rounding to decimal places. So let's say I've got 6.3827 and I want to round it to one decimal place. That means I'm going to cut after the first decimal place. Remember, decimal places refer to digits to the right of this point. So that's the first decimal place, that's the second, that's the third, and that's the fourth. So if I'm rounding to one decimal place, I'm going to cut there, so there is one decimal place, one number after the point. And that's either going to stay as 6.3, or it might change to 6.4. So this digit here might increase by 1. And that depends on the digit to the right of where you're cutting off. And again, it's the same rule. A 5 or bigger means that I need to round up. So this is going to be 6.4. Let's give another example of that. So 7.2776, and I want to round that to two decimal places. So there's my first, there's my second, cut there. Again, look at this digit to the right of my cut. That's a 7. So again, I need to round this last digit up by 1. So it becomes 7.28. One slightly more tricky example. Let's say I've got 8.6998 and I want to round it to 3 decimal places. Then I cut there. I look to the right of my cut, and I know I need to increase this 9 now by 1. Problem is, I can't increase a 9 by 1, so I will look left a bit and say, well, can I increase 99 by 1? Well, not really, because it becomes a 3-digit number. So I'll keep looking left and say, right, let's look at this then. Can I increase 699 by 1? Oh yes, I can do that. So that's 8.700. So this slight complexity occurs when you've got some 9s that you need to round up. And when you do, just keep looking left until you can kind of look at as low a number that could be rounded up by 1 without creating an extra digit. So 699 can become 700 if I add 1 to it. Okay, rounding, especially significant figures, is important when I've got a question that asks me to do this, which is to estimate the answer to something. Now, if it says estimate, it means they want a rough idea of an answer, and they don't want an exact answer, because if you give them an exact answer, you'll actually lose marks, strangely. So let's say I have to work out the cost of 39 toys that are £4.88 each. I'm asked to estimate the total cost of 39 toys if they're £4.88 each. So what I'll do is I'll round the numbers very roughly and ideally to one significant figure. So this will become 40, because it's nearly 40, and this of course will become £5, and 40 lots of £5, 5 lots of 4 is 20, put the 0 back on. So it's about £200, and it's really that easy to estimate because you don't have to spend much time doing the calculations, because by nature of the fact you've rounded them, they're much easier to work with. So what I've actually done is rounded these two numbers to one significant figure, but basically just round them so they're very easy to work with. So 39 is not an easy number to multiply, 40 is very close to 39 and is very easy to multiply. £4.88 is not very easy to multiply, £4.80 or £4.90 is not very easy to multiply, but £5 is, and that's nearly £5, so I use £5. So that's estimation. Right, one other thing we looked at was operations with fractions. So let's do a quick addition and subtraction of a fraction. So let's do 3/4 take away a 1/5. Now the golden rule here is I can't do this subtraction or an addition until these fractions have a common denominator, or in other words, until they have the same bottom number. So I have to make these two numbers match. So the lowest number I can think of that 4 goes into exactly and 5 goes into exactly is 20. So I'm actually going to change both fractions so they're written in 20ths. So I need a fraction equivalent to 3/4 that has a denominator of 20. So I spot here that I need to multiply the bottom by 5 to get to 20. So I must do the same to the top so that the fraction I get is equivalent to 3/4. So 3 times 5 is 15. So this fraction is equal to 15 over 20. A 1/5, if I times the bottom by 4, I'll get to 20. So I've spotted that. So I have to do the same to the top. So this becomes 4/20. So 1/5 is equivalent to 4/20. Now that the bottom numbers match, I can do the subtraction. 15/20 take 4/20 is 11/20. So that's 15 take 4. 20ths don't change, of course, because they're still 20ths. Even though I've taken 4 of the 15 of them away. So that's a subtraction. Addition, just the same, except at the end I add the top numbers. So let's go with 3/5 plus a 1/6. 3/5 plus a 1/6. Again, I can't do this until the bottom numbers match. So the lowest number I can think of that these go into is 30. So I'll change both fractions so they're written in 30ths. This one I'll need to times by 6, so I'll times the top by 6 and get 18 over 30. So 3/5 could be written as 18 over 30. This one I'll need to times the bottom by 5, so I'll do the same to the top. So this is 5 over 30, and then I can do the addition. 18 plus 5 is 23/30. Okay, a little bit of algebra, just to finish off with. if I gave you this rectangle and told you that this width here is x, and I told you that the length, this length here is 4 centimeters more than the width, then we need to be able to write a bit of algebra for that length. So we're saying that this length here is 4 centimeters more than the width. Now the width is x, so how do I write down 4 centimeters more than x? Well, it's x plus 4. So whatever x is plus another 4 centimeters, that's the length of there. I could have, of course, put 4 plus x, which would give me the same answer, which is to say 4 plus whatever the width is. Okay, so I've got an expression now for the length, and I'll now need, probably or possibly in an exam, to write down an expression for the perimeter. Now, the perimeter is the border of a shape, so it's all the way around. So the perimeter of this shape will be x plus 4 along the top, x down that side, x plus 4 along the bottom, and x up the side. Because it's a rectangle, the top length and the bottom length are the same, and the width on both sides are the same. So the perimeter is all these 4 lengths added up. So I can add up the x's separately. So x plus x plus x plus x is 4x. And then I've got a length of 4 there and a length of 4 there, so it's plus another 8. So that would be the perimeter of the shape. Okay, I hope this is helpful. I'll aim to put out another video shortly, and do let me know your feedback. Thank you.